People use underwater sound as a tool for exploring the ocean, such as mapping geological features on and beneath the sea floor, measuring the number of fish, and finding appropriate places for the construction of wind turbines. The Bureau of Ocean Energy Management, or BOEM, analyzes these sounds to determine how and where they should be used in order to avoid harassment of marine species. Two U.S. laws, the Marine Mammal Protection Act and the Endangered Species Act, require specific protocols to avoid or minimize harassment of marine animals. Regulatory agencies provide guidance on acoustic limits. If the sound level is above the threshold when it reaches an animal, it may result in behavioral harassment of that individual. If an animal is exposed to a sound below the limit, it would not be considered harassed. We classify these sound sources as de minimis, meaning they have minimal impact on marine species. These thresholds are useful, but they only focus on how loud the sound is and do not include other important characteristics of the sound source. A recent study completed by BOEM and the USGS closely examined high-resolution geophysical sources that are typically used to map the seafloor. The study characterized and classified a suite of sound sources based on their potential to affect marine species. The first characteristic was the frequency, or pitch, of the sound. Some resources transmit sounds that are above the hearing range of most marine mammals and are considered de minimis simply because the animals cannot hear them. The second factor is the amplitude, or how loud the sound is when it reaches an animal. Normally, the amplitude is defined as the source level from the device generating the sound, but sounds lose energy with distance, so by the time they reach an animal, the received level could be below the threshold, meaning the source is not impactful. Also, it's unlikely that a marine mammal will encounter an area where sound levels are high or significantly disturbing. Even in areas with very high densities of marine mammals, calculations show that a single individual would rarely receive high sound levels. This indicates that some louder sounds may be considered de minimis under most conditions. The width of the sound beam is also an important consideration in determining the impact of sound sources. Omnidirectional sources radiate sound energy equally in all directions, but many high-resolution geophysical sources have sound beams that are more narrow and only insonify a small part of the water column. Therefore, some acoustic sources can be considered de minimis because they only insonify a small volume of water, and thus are unlikely to be encountered by a marine mammal. Finally, it's important to consider the total duration of a sound source as it passes by an animal. Many high-resolution geophysical sources emit very short pulses of sounds. The number of pulses relative to the animal's position and the speed of survey vessels are used to determine the total duration of sound that an animal may encounter. Most animals will receive such a short total duration of sound that it can be considered de minimis, especially compared to all of the various sources they hear in a typical day. By evaluating these characteristics of active acoustic sources, most high-resolution geophysical sources, such as those used for surveying areas for renewable energy or sand resources, can be considered de minimis and are unlikely to result in harm to marine mammals. The findings of this research help agencies to determine which sources require regulatory review and mitigation, such as protected species observers to operate safely around marine species, and which sources do not. This provides us with a more complete understanding so that BOEM can confidently deploy high-resolution geophysical systems in support of the agency's mission to manage development of energy and mineral resources in an environmentally and economically responsible way. To learn more, visit boem.gov.